All right, welcome to virtual Math 8 classroom. Today we're going to look at 6.4. We finished off 6.1 through 6.3, and so we'll look at the distributive property today. So just as a bit of a review, we're going to compare where we've been to where we're going. 6.2, we would have set up different one-step or two-step equations like the following. So Naveed has $72 in her savings. And each week she'll save 24. So that's where we found this is going to be a variable. $24 a week plus the 72 she has. After how many weeks will she have 288? Okay, so that's what we've done, and where we're headed in 6.5 is stuff like this. So basically where we end up using something called the distributive property, where we put brackets in the situation somewhere. So Mark has some hockey cards, his friend gives him 3 more. So if he has some, that's what we don't know, that's our variable, X, and his friend gives him 3 more. So typically we start putting that into math language, 3 more cards. Mark says that if he now doubles the number of cards, so we can't just double X, we can't just make this 2X plus 3, but we have to double this entire thing. So this is where we have to actually put brackets around the 2 things that we're looking at so far. So some hockey cards plus 3, and now we're going to double that. Okay, and at what point will he have 20? So notice the difference. Here we've got a 2-step equation where we've got just the number, the coefficient multiplied by the variable. Here we've got the variable in brackets, and so that's kind of what we're going to be looking at in 6.4 and 6.5, the difference between that and recognizing the wording that goes with it. So this is called the distributive property, a question that involves this. So we're going to kind of backtrack and just look at what this actually looks like in a few different examples, but this is where we're headed, okay, towards 6.5. Okay, so a simple example here, the number 4 times 37, and I know in elementary they start to teach various ways of multiplying 2-digit numbers together. This is one way where we can think of it as 4, I don't know if you can see that, but it's splitting the 37 into 30 and 7, and so what we can essentially do is write it like this, 4 times 30 plus 7. Right? And so splitting it up, we can basically, what we can do is figure out this rectangle, 4 times 30. We can do some quick mental math. 4 times 30 is 120. And we can do 4 times 7, because that's the size of this rectangle. And if we do it like this, then the area, or in other words, 4 times 37 is just going to be this box plus this box. So it just becomes 120 plus 28, which is going to equal 148. So what we've basically done here is the distributive property. We've taken this 37 and we split it up into 2 terms, okay? And so we're going to be using and working with that idea in this section 6.4, okay? So another example here. Gina's restaurant has round tables. Each table seats 5 people. Some tables are in the lounge, some in the patio, okay? But each table will seat 5 people. So now it tells us there are 20 tables in the lounge, 8 tables on the patio. How can we actually figure this out? Well, some people might say, okay, just there's 28 tables altogether, 20 tables in the lounge and 8 tables altogether. There's 5 people per table, and so they can basically put this together. 5 times 20 plus 8 people. Put it together, right? 20 plus 8 is 28. So we could just do 5 times 28 and actually calculate the answer. Another way to do it is to use the distributive property. We'll get more into that in a minute, but we can actually set it up as 5 per table and then 20 plus 8. So we might be interested in actually how many people are going to be inside, how many people outside, so then we can split this question up slightly differently. We can multiply the 5 by 20. That tells us how many people are in the lounge. And then we can do 5 times 8, and that'll tell me how many people are outside, and put them together. Okay, if I just calculated this straight away, I'd get the answer as well. So notice, just 2 different ways of attacking or trying to figure out the exact same question. One is putting the stuff in brackets together, the other one is splitting these two things up, multiplying 5 times 20, multiplying 5 times 8. And this process here is the way that we use the distributive property, where we distribute the number on the outside of brackets times those two numbers on the inside. Okay, so that's kind of what we're going to look at in this section. Any questions? No questions? That's amazing. You guys are so smart. All right, so exact same situation here. Charity sells pots of flowers for $10 each to raise money. 8 people pay with a $10 bill, 8 people pay with check. Do you guys even know what a check is anymore? $10 checks. So you might say, if you're just the one organizing this fundraiser, you might just say, okay, well, we have 8 plus 5, we have 13 people times $10. Simple, we made $130. But maybe you're the person who has to go to the bank, and then you actually have to split this stuff up. If you've ever made the invoice or whatever, you might have to actually, okay, we have this much cash, this much in checks. So you might have to do that in a slightly different way. And so that's where the distributive property comes in. You've got $10 a piece, 8 in cash, 5 in check. So I might want to know both. So I'm going to do 10 times 8 is 80, 10 times 5 is 50, and in the end I get the same amount, but this just splits up the two terms, right? And so that's the distributive property. So we'll look at a few examples just simply with the numbers and get into some negatives, but it's all kind of the same idea. They show often in the book kind of the rectangle model of taking 1-digit number multiplied by a 2-digit number, right? So if you ever have something on the outside of brackets and you have two terms on the inside, it's always the same. Math patterns, always the same. A times B, A times C. So whatever these numbers happen to be, we always do the same 2 steps. We do A times B, which would just be AB, plus whatever you have as the other term, so A times C. Okay, so this is always going to be equal to this, whatever numbers you plug in for A, B, and C. Now we don't want to deal with letters all the time, but we are going to come across some of that stuff. Okay, so we'll just jump into these examples, and then hopefully you can have a little bit of an understanding of how this distributive property works. Okay, so distributive property, right now we're not solving. We're not saying A equals an answer or C equals an answer. We're just actually expanding. So sometimes you'll be asked in this section, expand. It's the same thing as saying use the distributive property. Okay, so write the expression as the sum of terms. So the sum of terms just means 2 terms added together. So right now we've got a multiplication of 2 things, but we're going to actually expand it out, and then it's going to be this plus this. Okay, and it's always going to work the same. Okay, so here 7 and then C plus 2, the distributive property says I can multiply that number on the outside by both terms on the inside. Okay, so 7C plus 14. There, I've expanded it out. 7 times C is 7C. 7 times 2 is 14. Okay, pretty straightforward. No questions? Okay, I'll move on. 42 A plus B. Okay, now I've got, here I had a letter and a number. It doesn't matter if it's a letter or a number or anything. The rule still applies. I take that number on the outside and I multiply it by both things, both terms on the inside. So 42 times A, we just simply write, if we remember from grade 7 math language, 42 times a number is just 42A, just like here, 7C, right? 42 times B is just 42B. Notice in both of these answers, it's not really an answer, it's just a different form, right? Both of these answers we have the sum of 2 terms. This is a term, this is a term, they're being added, right? So we're just expanding things out right now. Okay, in 6.5, we're going to actually add like a 7C plus 14 equals 15, and then we're going to actually work backwards and solve. All right, but we'll leave that for another time. All right, so negatives, always got to tackle negatives. For some reason, negatives throw everyone off, but if we remember, the process is the same. We take that number on the outside, we multiply it by both terms on the inside, then we can't forget it because we're just doing the same thing. Okay, so here, -3, and then being multiplied by x plus 5, we do the distributive property, -3x. So -3 times x is just -3x. We write that as the coefficient and the variable. Okay, then we have to take -3 times +5, which just becomes -15. So there's my expanded answer. It's not x equals something, but it's just a different form of the same thing. It's the distributive property applied to the terms. Okay? Negative. So we have to remember our integers. So here's another one. This one's got negatives on the outside and on the inside. But again, if we remember the process, then we're not going to forget how it goes. So -4 times -5. We remember back to integer rules when we multiply them. Two negatives being multiplied equals a positive. -4 times a positive a just becomes -4a. Now kids always ask, is this a negative or is this a minus? Doesn't matter how you think of it. It's either way there's going to be a negative symbol or a minus symbol. So you could think of it as -4a, or you technically could think of it as plus -4a. But either way, this is a negative being attached to that second term. Okay. Okay, so far so good, hopefully. Okay, no real difference here, but just getting a bit of practice with this stuff. 6 times x minus 3, the stuff in brackets could also be a negative or a subtraction. So again, I always say, take that negative and apply it to whatever comes after. And then for the rest, just multiply the term, multiply the other term. So 6, and then x minus 3, multiply both. By the way, I always do this. It's not a mandatory thing, but it just helps you remember that you have to multiply that term on the outside by both, okay? Because that's a common mistake as well. Students will do this. They'll do 6x minus 3. And they forgot to distribute the 6 onto the 3. And I find for myself, that just gives me a reminder to do it to both. So it's kind of up to you. If you don't really need to do those markings, fine. But just make sure you always multiply by both. So if you did the 6 times x, good. Make sure you do the 6 times the -3, which becomes -18. Okay, last one, and then you can go to work. 5 times 8, and 5 times -c. Okay, so if you want, you can even do that extra step of saying what you're multiplying and then putting it in. So 5 times 8 is 40, and then a subtraction, 5 times c is 5c, so minus 5c. So there's your answer. There's your answer. Okay. Wow, such a quiet class. This is refreshing. Page 342. We've got a few questions for you to practice there. 6 through 8, 11, 12, 14 through 16, and 18. So hopefully that makes some sense.